Hi guys, I hope you're good since last video. Have a break, have a rest. Did you watch all previous videos? I see more people following the channel, but you are not watching to the end. Learning is a slow and repetitive process. Don't miss a piece, as you literally could just open your terminal and follow along. Hands-on is the best. As a reminder, I'm learning Rust just to be able in the future to implement it in my Python projects, offloading to Rust some heavy tasks, making my Python more efficient. Maturing PyO3 exists, but I take the chance to go lower level than Python to pimp my skills up. So do you, right? Okay, in this video, we are going to focus on strings. We will have the first part to explain a bit what are the strings, and the second part will be the hands-on part with some interesting examples. There will be a short 5-second break just to give you the chance to open the fridge and grab something to eat while enjoying easily learning Rust. Okay, let's get started. Strings. So let's compare a little bit Rust versus Python. So Python strings, the allocation is a high-level, dynamically typed, immutable sequences of Unicode characters. Memory management is abstracted away from the user. Referencing variables reference string object. Multiple variables can reference the same string object. In Rust strings are more complex due to ownership borrowing on lifetimes. Lifetimes, we're going to see it maybe in the future videos. Two main string types, string, owned, mutable, and the ampersand string, which is the end string notation, which is the borrowed string slice, immutable. In the Rust side, the allocation is a heap allocated. So you have the heap, you have the stack. Heap allocated, so you can it's more dynamic. Memory is allocated when the string is created. Memory is automatically deallocated when the string goes out of the scope. So this is what is called the lifetime. Ampersand string, the other one of Rust, points to a sequence of UTF-8 bytes stored elsewhere. Example in a string or as a string literal. Referencing, ownership, Rust ownership and borrowing rules dedicate how strings are referenced. Borrowing allows for references to data without taking ownership, ensures memory safety without a garbage collector. So in Python, it's abstracted away from the user. There's a garbage collector doing everything on the background, while in Rust, you need to manage it. That's why we're seeing strings, actually. Extending on the truncating strings. Let's see through those examples. Python, immutable nature, so you cannot modify a string in place. Operations that appear to modify a string actually create a new string, so there's a new object created. So here in this example, we have extending the string. S equal to hello, S plus equal word. So here it creates a new string. This one here is immutable. Truncating strings. S it equal hello world. And here you have the S, and we grab the 5 first words. Create a new string object hello. Letters. Memory implications. frequent modifications can lead to increase in memory usage due to the creation of multiple string objects. For heavy string manipulations, using byte array or IO or string IO, for example here, string IO, that's something that you have used in the videos with the different AI agents, can be more efficient. So for Python, only if it is a heavy strings manipulation, this can help. Otherwise, you just use the normal operations, it's pretty quick. Rust mutable strings, so string first, can be modified in place, provides methods to extend and truncate without reallocating when possible. Extending the string, so here we create a mutable string, hello. We're gonna be appending to that string word, so it modified the original string, but in place. So if you were to give, maybe here, put a let name of variable equal to this, it would return nothing, it will be empty, because it's just doing the operation on the string. That's what is good, while here in Python, it keeps creating new strings. So the implication here in memory is it takes more space, while here it's more efficient. So truncating strings, here we use a mutable variable s, hello world, we truncate 5, we get the same result as in Python. So same here, this is done in place. Memory implications, efficient memory usage due to in-place modifications, may reallocate memory if capacity is exceeded when extending. So borrowing and slicing strings. So in Python, you can slice strings to create substrings. Slicing creates a new string object, so as we've seen before. But in Rust, you will see it will be a bit different. Referencing substrings, no concept of borrowing. Variables reference objects directly. Substrings are new objects. So here, same as the example before, it keeps creating new strings. So the substring is an object, a new one. While in Rust, the slicing, string slice, here we don't use the string, but we use the reference to the string. So views into a string without owning it. Slicing does not create new allocation. So no new allocation. Hello world, and here we just get the 5. You see we use here the reference of the string, so the slice, and we're gonna get those 5 characters, 5 letters. So borrowing, the ampersand operator creates a reference to the data, ensures safety through lifetimes. So the scope, how long, so it's lifetimes is about the scope, how long a variable lives. The slice cannot outlive the original string. So here we make sure that the reference here is not outliving the original string. So memory implication, efficient, as no new data is allocated. Borrowed, sliced. Borrowed slices prevent data races on the dangling pointer. So this is dangling pointer. If, for example, you have a reference to a string, but the original string doesn't exist anymore, but the reference is still there, referring to what? To nothing, because there's nothing behind. So to prevent this, Rust has implemented those rules of borrowing, of being an owner, to not get those compiling issues. Methods and manipulate strings. So Python string methods, common methods. So here I will be just listing some different methods that you can use in Python. So concatenation, you can use plus, join, split, and so on. Just gonna go to the example now. And after here, the example, lower, hello, word in the lower. So we have lower characters, replace, that's how we use it. Put the word here that we want to be placing, and the one that, that we want to replace, and the new word, which is going to take its place. And split, here just to split on, here we don't put anything, that means it's going to split on the white spaces, and we get a list like that. That's how we do in Python. In the rest, it looks a bit like in Python. So REST string methods creation. We create a string. It can be an empty string like that. We can create a string this way, using here the string, I think it's a struct, hello. Or you can create here the string by writing your string, like in Python, like you would write it. And you use the method toString, because this is in Rust, using the double quotes, it's a reference to the string. It's an ampersand string, toString, so it becomes an owned string. Concatenation, you have those two, S1 and S2 strings. You can't concatenate those two directly. So the first one here on the left has to be an owned variable, and after you can concatenate it only with the reference of another variable. So it's important to know that, otherwise you're going to get a compiling error. And here S1, the S1, because we're using it here, when it arrives to the plus, S1 here will lose the ownership. So the ownership will be to the S3 now. So S1 is moved, and S3 becomes hello world. So here there's something happening with the ownership of S1, which is going to be moving when this operation is going to be made, the plus. Appending, so we use a mutable variable, hello, we append the character, we append the string. So to append the character, you use the method push. To append the string, you use the method push_string. So the slice, here this is a slice of a string, as we've seen here. And this one here, you see we use single quotes. When you use single quotes in Rust, this is character. When you use push, you can push one character, which is here white space. Splitting, so splitting, here we use the word, and we split on the white spaces. This is a method that you can use. And you're going to be printing and with the formatting. Replacing, we're going to go through different examples. That's the best way to see it and understand it, picture it. So here we're going to be replacing, we're still in Rust now, we're not showing any Python example. This is all Rust. So string from hello, and we use a replace. Word, Rust, hello Rust. It's almost the same as in Python. Case conversion. So lower and upper. To lowercase, to underscore uppercase. So you get the concept here. You get all in lowercase, and here all in uppercase. Trimming, we have white spaces. We want to trim, you just put trim like that, like you would use in Python strip. And here you get hello world at the beginning and at the end. We get rid of all the white spaces. Searching, here we can be evaluating. So we use here the method find s, which has the string hello world. S find, we need to find a word. We evaluate. So if let sum, so if we find the index, println found at index, so we say at which index we have found it. So you see here word is it's not a string. It's just you write word and you put double quotes, which means it's a okay. So I give you the answer. It's a reference to a string. That's what we've said before. So it's an ampersand string. That's why here we get an index in the sum. Now, memory management and safety. So in Python, automatic memory management, there's a garbage collector which handles the memory deallocation. Reference counting determines when an object is no longer used. No manual control. Developers do not need to manage memory allocation and deallocation. Unicode handling. Strings are sequences of Unicode characters. Internally uses UCS2 or 4 encoding depending on the build. While in Rust, there's more stuff to do. So Rust ownership and borrowing. The compiler enforces rules that ensure memory safety. Ownership determines who is responsible for deallocating memory and the lifetime of the string. So lifetime ensures references are valid as long as they are used. UTF-8 encoding, so all strings are UTF-8 encoded. String slices, ampersand string, are guaranteed to be valid UTF-8 references. Manual control with safety. Developers have control over when and how memory is allocated and deallocated. The compiler checks prevent common memory errors. And here I just put there's more headache, but it's better than Python, which creates new objects. So that's why here we get it to be managed in a better way than in Python. Here what is nice is all automatic, but you have the creation of objects, while here it's doing everything. We're focusing on the string here. So it's going to be here just transforming the string in place or playing with the reference of the string, not touching it at all, which is better for the memory efficiency. So let's extend a bit, extending on truncating in detail. So Rust appending to a string. So we've seen that before. We append word, concatenating multiple strings. So before here we used the plus, but this time I want to show you this one, which is format. You can use format. At this time you use those two values. Uses formatting macro. Memory implication. Push underscore str and the push methods modify the string in place if capacity allows. So that's what is good, is that in Rust is trying to do everything those operations in place. The plus operator moves ownership, as we've seen before, has moved the ownership. So when the plus happens, the ownership of the left variable is moved and may result in reallocation. And the format, this one here that we see here, is a macro which creates a new string. This is interesting. Rust truncating with truncate. So here we have a string, truncate 5 to get hello. We've seen this example before. Slicing with ranges. Same here again. Hello. Now you should be a professional of this, you should understand everything. And this is a reference. So memory implications, truncate modifies the string in place also, and slicing create a reference without allocating new memory. So this page here shows you why Rust string management is better than in Python, even if in Python is abstracted away from the developer. For 7 points, so common string operations, iterating over characters. So doing an iteration is just for char in S. That's how you print all the different characters. This will be the Python way. The Rust way is almost the same. Let S, we create the string for C in S, and here we have to use this method chars, which prints here the characters. String lengths, Python, hello, length, len, S, and here in Rust it's the same. We use a len. Just here is different, but yeah, 5 bytes. So that's the answer, 5 and 5. For character counts, may differ due to UTF-8 encoding. So if you have characters and you want to print, let's say 5 for example here, you would use a variable, or you just print this directly, but you need to add count. So if you use S chars, so here you get all the characters. See here we got all the characters and we're doing a loop through those characters to print those. Here if you want to count, say how many characters we have here and return a number, you can do it like that also. So you can use length or character count. Accessing characters in Python, so you just access those like that. In Rust, you cannot index strings by integer. So due to UTF-8 encoding, indexing by integer could lead to invalid memory access. So using slicing or iterators instead. So that's why we use slicing in Rust here, as in the example before, is because we can't use integer. That's why we have to use the reference of it. The reference of the string, when you do like that, this is going to be an index. It's going to be a usize. And the usize type, so not int, not integer type, will be able to do the slicing like that. Little bit more before going to the terminal. Rust UTF-8 encoding. String are UTF-8 encoded. String slices, %string are slices of UTF-8 bytes. We've said it before. So we just want to here talk about bytes versus characters. String and %string operates on bytes. Use .chart method to iterate over Unicode scalar values. Ownership and lifetimes in Rust. So ownership transfer, here S1, let S2 equal S1, the ownership of S1 is moved to here. You already know that because we've been talking about that since the beginning, but here as we're focusing on strings, we're just going to go over. If someone want to check out to this video as a standalone and doesn't need to go and check all of the other videos to find where we were talking about that. Cloning, same here. You can clone S1 clone, deep copy of S1. So here the ownership stays, S1 stays still the owner, so you can still print it. On the next line, on S2, it's a new variable. Borrowing. Let S1 string And here we use to calculate in a function, for example, we pass the reference of S1. So S1 is still the owner, and here we're just borrowing that reference. And here you have we want the length of S, so we can use the reference of a string. See here we put reference of string, and we come back with get a usize. See, slen usize, because it's all UTF-8 bytes. Mutable references, let mut s, we get our string. And here, if you want to pass to a function a mutable string, that's how you define it. So you put ampersand mut string, and here ampersand mut, and you put the variable s. Okay, so while here you put ampersand in front of the variable name, while you're using the keyword mut, the ampersand is pushed left to the mut keyword. And after here, we're just going to be appending word to hello. So lifetimes, we will see that later on, not now, but it ensures that references do not outlive the data. 0.2, dangling references we were talking about before. So having an ampersand, which is a reference of a string, if the string doesn't exist, we don't want the reference to still exist in the memory. So this can cause errors. The compiler can often infer lifetimes. So we've been using Rust, we've been doing a function and everything. We haven't implemented the lifetimes. That means that the compiler can infer those lifetimes. It knows how long a variable is available. Enclosed in string, so the string literals. Just a single quote in Python, double quote, triple quote. You just do multi-quotes for Python. Immutable strings, string objects. While in Rust, you have to be careful with that. They are ampersand. You have this little code. This is generics. We haven't seen it yet, but this is just to say it's ampersand str. So it's a reference of a string type stored in the program's binary, and I have a static lifetime. So we use here static. How long the variable lives linked to scope. So lifetimes here is going to check the different scope. So for example here in the function, this is enclosed in the function scope. So this variable here is in the scope of the function. Outside of the function, it's another scope. So when you use here double quotes, I told you just a few slides before, but double quotes in Python like that, this is a string. But in Rust, it's not a string. It's a reference to a string. Okay? Now we're ready. Let's go to the terminal. That's what we got before. Now let's create a new file. Let's call it strings.rs. We'll be commenting along while we're coding. We're going to use only one public function, because here we're just dealing with strings, and put different examples. In one by one. So we're going to do different examples, putting all in one function, and commenting on each. So it's very important to see this hands-on, to see how we're going to manipulate the strings, just to get the learning that we've seen in the first part, the information part. So here you will be able to use a few examples. The number of types returned, and use probably string. Yeah, we're going to use those tuples, returning as a tuple. Example 1, truncate, replace, slice. Let's create our function. Public, so pubfn string underscore string, so string raw str, which is going to return a tuple of strings. We're going to define after how many we need, but I want to show you it like that, so that the compiler is going to talk to you. I believe that you're going to understand the compiler better than me when I speak, and that's how you relearn, by iterating over those compiler errors. So example 1, truncate, replace, slice. We got our title. Let's start with the example, truncate. So what I'm going to do, I'm going to write all those examples, but they will be linked between each other. And after, when we pass to example 2, we are going to comment out this part and start with a new logic. So we create here a mutable reference. So it's a string crowded Shibuya. We're going to print. So I said mutable reference. We create a mutable variable s of type string. We're going to be printing it. So we're going to focus on everything around the string. So I'm not going to implement any display or anything like that. That's why you will see me printing using the debug mode. So using the colon, question mark, as here it is a reference. It is a mutable string. After here, we create another variable down there, truncate. And we're going to truncate 7. So 0. Just going to count the indexes. Here we have 6 at the end for D, and after 7. So we take the number 7, and that's where we're going to truncate from. Okay? So truncate means that's everything coming after, it's going to disappear. Going to get rid of Shibuya. Okay, so crowded should stay, and the Shibuya should disappear. Let's print this. This is an interesting part, just to see if you remember what we've learned in the first part. So here I created a variable. I said it's equal to the operation truncate on the mutable string s, and I'm going to just print it here, s truncated, and we're going to see what is going to print actually. So this one is interesting, and we will explain again. I've explained it already before, but we'll explain again. on terminal build. So when we run our cargo build, we will see what's going to happen. We're going to close those comments. This one also. I'm going to leave the title for the moment so that you can see the different examples. So here we're going to be starting the other one, which is replace. So we've truncated this word. This sentence, crowd Shibuya. So here we expect S to be equal to crowded, because we got rid of the Shibuya and the white space also. Let S2 replaced. We're going to be playing with it. That's how we're going to link all those examples. S2 replace crowd, so the word already existing, with loud. So you see here we don't take crowded, the full word, we just take a part of it. So we want to be having crowd being replaced by loud. So the word after that should be loaded instead of crowded. Let's print it. So here is just a string. So we should be able to print it without any debug mode. Crowd and load. So this you got it. Truncate, replace. Now it's time to slice. So here, what can we expect? Tell me. We can expect S2 replaced, S2 replaced to be equal to load. Let's create a variable. Let S3 we're going to use the variable that we had before. We're going to clone it. So that we can manipulate it. So S3 print this is just to have on the terminal we'll be able to see all those variables and how the variable evolves. So we expect just let me create a variable here. Let S3 sliced. I'm going to slice it. Ampersand S3 0 1. I'm just gonna maybe show you the yes. Let's check the indexes. So low, that's what we want. Let's get low. So we have 0, 1, 2, 3, 4. And this one, 0, 1, that's the low. So here what we want from 0 to 1 included. Okay. Therefore, here, S3 sliced should be equal to low. Here you can see equal to low. Capital O, capital L, and O. We print ln. S3 sliced. Use the debug mode. S3 sliced. Might print the types also. So here I need also to return the tuple. So S is replaced, and S3 slice to string, because this is a reference to a string. The slice one, we use the ampersand. So we need to convert it back to a string. We clone. It's a reference to a string, so we use here toString to be able to return a string. Just comment. S3 slice is an ampersand string. That's why here we need to convert it. That's why we use the debugger, because it's a reference to a string. So let's close the comments. So here we're going to return 1, 2, 3 strings. 1, 2, 3 strings. Close those comments. So this function here, just ignore it. Just me who want to make this example a little bit better by printing the types. So you can see on the terminal which types are those some of those variables. So function print type of. I'm just gonna be creating type slice size. Let's put underscore. So the reference of the type. I'm going to print using the method from the standard library. Standard library, any type name, and here I put the type. Just going to copy this. There is one that we need to see. So here, let's check this one. The S3 sliced. Let's print the type of it. Maybe here we don't even need println. I'm just going to use the function directly on it. Okay. I think we're good to go to the terminal and see some red and come back, fix it. And after we get the right result. So I'll close this one here, that one here. Let's import our module. Go to the main.rs. And we're going to be printing the function from there. Strings, that's the name of the module. And we're going to be printing the function using the formatting with a colon question mark. String underscore or underscore string. That's it. So we can call it cargo run. Is it gonna work? No. Okay, one comment we didn't close. So let's close the comments. This one here, we need to put the module in front of the function. Strings, double colon. Let's run it again. Nice. We got a lot of those. So we're missing semicolons and some variables. So here one semicolon and the name of the variables. This is S2 replaced, not SE replaced. So here same, S2 replaced, not SE replaced. Okay, I forgot another one, which is the one that we return at the end. Let's go back. And this one is the last one. Okay, all the errors are fixed. Let's clear this. Have a nice terminal. It's nice outputs. Okay, let's see this evolve. We have S, Credit Shibuya, truncated, nothing. Why? S2 replaced, loaded. So we have a changed crowd to load. Okay, so now S3. So S3 will be loaded, and we have sliced the loaded S3 and got the 2. And we have str as a type for S3 sliced, and here the truncated. As I told you during the explanation, the first part of the video is returning nothing. Why? Because it's just an operation in place. It's not like in Python. It's not creating a new variable, a new string. So let's comment this so that you can understand that truncates, return nothing. Why? Because it is changing S, it is truncating S in place. In place. Okay. So that's why it's not going to return anything. So no need to assign a variable. So here in place means that underscore s underscore truncated is doing an operation on s. It's just a worker, just coming, doing the operation, and after just gonna stop. It's not holding any variable. So it is not like in Python, creating a new string. Okay, new object. Okay, so this was the first example. Truncate, replace, slice. As promised, we are going to comment this out. Let's comment this out. Here, just this is how many strings this is how many strings are returned. 3. 1, 2, and 3 strings. Therefore, do not forget to change the function number of returned strings. Okay. Example 2, .len and .charts .counts. So here len and chars counts. I'm going to be also trying to print here the types, so we're going to see some more details. Let's create our variable. Now we're going to customize a bit. We're going to go back in Shibuya. Let's queue at Starbucks Shibuya. No. What do I want to do here? Let's do it like that. Create a string this way. 20 people dot to string. So 20 people is an ampersand string, and we use the .toString to create a string from it. So here are the lengths. Q at Starbucks Shibuya.len. We use the method len on it. Let the length type equal the type of a Q at Starbucks Shibuya. No, maybe length. That's the one we want to see. This is a reference. We're going to print a nice sentence here. Length. If I'm able to write it, let me just do it like that. Here first. Should we print it directly or put it in a sentence? Because we can put in a variable. So I'm just going to print it directly without creating a sentence. So let characters in Q. We use the Q at Starbucks Shibuya variable. We're going to use .charts, .count on it. Okay, we keep going. Let's characters Q type, or should I call it directly? Print type of. Let's copy it. Ampersand character in Q, semicolon. Okay, so we take the variable, we get the length, we get the type of that length. We call charts that count on that variable. Characters, and after here we create this variable because I want to put it in a sentence this time. All this is manipulating strings in different ways. We're seeing those methods and we're using different ways of using those strings in prints. Interpolating those, passing one string to another. So that's what we're doing basically. Chars.count type. Use the debug print. While charts only type. So here I'm going to be printing two different ones. The one which is the chars count, but we want to know what the chars is doing. behind the scene. So we're going to also print it. So characters in queue type. And we're going to get this variable here and chars only. Perfect. So that we can have an output of how it looks, what are the operations done behind the scene. After here, we're going to return our tuple. So we need length, toString, and we need characters in queue, toString. Let me close this comment. Before we go to the terminal, just review the code, check if you spot any errors, and tell me those. Otherwise, we're gonna get compiler error, but you're gonna see those and we're gonna come back if I did any typo or something like that. So character in queue, we created the variable, we get the length of it. Here we're using on that variable chars count, character count. After we printed the type, and we're storing that result in a character in queue type. And here we create a sentence using those variables and formatting this string. We return the length toString, and the character in queue, toString. Cargo ren. Let's clean this. You're gonna get a lot of errors probably, yes. So we need the full screen for that. Okay, what do we have? Have a local variable with similar name. So here is a typo. Local variable name with similar. Okay, another one. So what's the typo? Characters, the first one, TC, okay. Characters, queue type, and here it says help a local variable with the similar name exists. Character in queue type. So I forgot the in queue type. Okay, that's the one coming back again and again. Is this characters? Okay, it keeps repeating because we've done that. Okay, we call in that name several times in different ways. And here we're missing in. Okay, another error. String. We're returning 3 strings on the top of the function, but we actually need only 2 to be returned. So the tuple, we need to change it here at the top. First, let me check here. Let me check down here the typos. So this one I've spotted it. Characters. Where is the other one? In queue, characters in queue. This is good. Okay, this one also. In, I got the in. Here, that's the one. in one, two. So we have two strings here. So that's good that you've seen the error for those. The compiler is showing you how many strings we have in the tuple, and the discrepancy with the returned, the promised returned number of variable. So here we say 3, but we have only 2. So we put only 2 strings here for this example. Cargo run. Okay, this is just a comment. It's good to comment, but you have to close it. Now we should be fine. Let's clear this. We played with the terminal, so we have a usize, another usize, character count type. We have nothing, means that this is done in place, while chars only type is chars, and you see what's happened when we call only chars. You see, it's going to be creating a list with all the characters. And here we have the numbers. So when you print length or when you print chars dot counts, you get the same number, 9 and 9 at the end. This is different ways of doing it. As you see under the hood, chars, it's going to create a list of those characters, and it's going to be, after count, we'll be able to count on that array of characters. Let's go to the next example. Example 3. We're going to use here, we're going to check single quote versus double quote and the dot next method. The dot next method is also interesting. That's for the iterators. So when you're doing a for loop, any iteration, instead you can decide to not do a for loop and use the dot next method. So iterator with dot next. Interesting. Yes. So if you're following along using a terminal on the side, you will see this one here. It's quite nice. So let's stay in the Japanese theme. Let mute, we use a mutable variable, purikura. String, we create a string, rejuvenate, through, purikura, 3 dots, we close it. After here, I'm going to push, dot push. I'm going to use the method that you've seen in the explanation part. I'm using single quotes and pushing a character to that string. Purikura is not str, it's push underscore str. So here I'm going to use another character so that I can create an arrow. So I'm going to push 2 characters, so we're going to get the arrow created like that. We're going to be printing Purikura is, and we're going to have the representation of the string. We don't need the formatter here, so we can use empty curly braces to print it. Character equal single quotes So when you have single quotes, you can push one character at a time. We append to string with dot push str. So here we're just using push and push because we're pushing two different characters. Okay, so single quotes, push. So you'll be an expert of string manipulation after that. Purikura dot. Here I'm going to use push string. And we're going to add a space. And after we're going to extend the sentence. Super photos. Alright. So if you know what Purikura is, you know. If you don't know, just type it to Google and you go on Google Image straight away to see what it is. Println Purikura is now. We just build this sentence for the terminal to look cool. And here we put Purikura in. It's mutable. Mutable means that we can modify it. That's why we could push those variables, those characters or those strings. So reference of a string here, because we're using double quotes. Okay, this is a string. Slice. Append to string. So same as the plus. You know, when you're using plus, on the left you have the owned variable, on the right you have the reference to a string. Here we're just pushing, we're appending to it. We're appending to it all character. This is how they encoded. That's why you can do those operations. Now, we did the push. We need to play with it. So now I will show what is .next. So .next method, what I'm going to do is it doing and how iterators work in general. Let's create a variable called Purikura clone. So we're going to now copy the state of Purikura. We have our copy. We can play with it. We're going to evaluate. Let mute word iterator. So here we're going to define, not evaluate, a variable. Let mute, a mutable variable. Purikura clone dot split white space. Okay, so I put it in a variable. Why I'm doing that? We could have used a for loop using something like forward in Purikura underscore clone dot split underscore white space. So the split white space is going to create an array. array, which is going to be splitting the sentence wherever there's a white space. So first it's going to split it. We're going to see on the terminal in details. So let's go like that first. What is happening? Steps, and choose to not iterate over. So here we're not going to be using the for loop. We're going to put it in a variable, and we're going to be controlling or just showing the different steps of the iteration through the polycura underscore clone string. So the .next will help to navigate that string words. We're going to see it here now. So there's a lot of comments here, but it's better just to explain it. Let words underscore iterator underscore type. So this word iterator type is a variable that we're going to reuse to print, because we want to see the type of word iterator, the reference of word iterator. We're borrowing it just to check the type, because we want to see what is happening behind the scenes. So let's build here a nice sentence. Word iterator is, we need the debugger here. We're going to use two variables. And its type is, and here we can use the debugger same to format it. So word iterator, and the second variable will be the word iterator type. Let next word. Now I'm going to create a variable in which I'm going to call the .next method. So word iterator, we're going to call the next word, and we're going to print it so that you'll be able to see what's happened. Next word is, we use the debugger, and type is, same here, we're going to print both. So next word, and here I'm just going to use the function directly here in the print type of next word, the reference of next word. Okay. It's better to create another variable. I'm just going to do it like that. Should we now close this or not? Yes, let's return the tuple now. So in our tuple, we have two variables, two strings. The function is already returning two strings, so we won't get this error anymore. Polycura, word iterator, next. So we're calling next here again. And this is like calling next twice on the iterator. So when you create the split white space, nothing happens. When you start iterating through that, .next is gonna be showing word one after the other. So after here, I'm using a method which is gonna be panicking if you arrive to the end, because you can use next after next encore, again print next, but at one moment you're gonna get an error because there's nothing to print anymore. There's no world to access to anymore, because it's actually consuming it. So .expect, just here we do a little parenthesis on that. It's a method. Here is to panic if no value is found. Okay, meaning the iterator arrived at the end. But let's keep commenting here. But I use it as well to be able to get the value. So it's gonna also unpack, because next is not just returning the value like that. It's not that easy. So the next, we want a string. That's what we want. But when you use next, what you get, it's an option. As we've seen in the options are returning some or none. So we will see that the next type is option. So we need to convert. To unwrap that, and expect is going to do that for us. It's going to unwrap that. Otherwise, if it receives none, it's going to be panicking. And the message that you have written inside the expect method will be printed into the terminal. An error occurred while trying to access the next value. So this to get some, the some side value. The expect method unwraps it. So that's how we're gonna get our value back to us. So behind the scene, when we explain it like that, it looks complicated, but you can just use .expect if you want. You can also use what we've seen before. Just gonna do this first, check everything is closed. With Poricora, we push those characters, we push this reference of a string. After that, we clone it, we make a copy of Poricora. Use a mutable variable, because we're going to be changing word iterator. Split white space, iterate through, but in a passive way, lazy way. And after here, we print the type, and after here we call next on that mutable iterator, which is using the iterator split white space method. And after we're going to print it, and here we're going to call it again with the expect to unwrap the answer. Let me just to make it clear, because we've seen that before, so you can relate. Instead of using expect, what we could have done here. So just let me write it here. Instead of expect, we could have used something that you've seen before. How would you unwrap an option? Match or if let. We've seen if let and match before, and this is a way that we could have used. I'm going to comment it out after. I'm not going to use it, but here I just say like that, and I'm going to show you an example of how we could have done it. Let's say we have a variable, let final output equal match. After here we do the match word iterator. So we want to match on that. Next. And here we have more control, because if it is sum, we return something. If it is not sum, we don't panic, we don't crash the application for that. We just control the error. So sum word here is just a placeholder, as you've seen before. Word to string, because we want a string back to us. So this is one option, one of the options. As option is returning sum or none. So here we could get a string back, like that. After we have the other side of the option, none. We use the arrow. And after here we can just return, for example here, an empty string, which is not going to be creating any error. It's just going to be returning an empty string to say there's nothing anymore. Return empty string to not panic. Panic. Okay. So, word iterator dot next is of type option. Now you got it. So its return is a sum or none. Returns yes. Okay, so now we can maybe comment this out. But you see we can use match. Just define a variable, use match. That variable is going to hold the return value of sum or the return value of none. So you won't get any error on the compiler. We're good with that. Hope that there's no error this time. Let's see. We're not scared about the compiler. I'm just gonna go cargo run. Yes. Ah, good. This time it's alright. I just forgot one semicolon, which is can happen. Here. Let's go cargo run. Wow, we got a nice output. So Polycora that's the first one, where we have pushed the two characters here and here. So the two characters to have this arrow. After that, we have pushed reference of a string. Polycora now rejuvenates through Polycora character, and here the reference of a string, super photos. And here white space, this is the type, just an iterator white space. And we have printed the word iterator is split white space, inner, filter, iter, so iteration, split internal, a stack, create an A stack, Purikura. So this is the output that we got here. So that's the new state of Purikura. Character indices, front offset 0, iteration. After here, we're gonna get this chars array. You see, we got this array. And the white spaces will be here. So you see, under the hood, it's not going to be splitting directly on the white spaces. It's going to be getting all the characters to be able to detect those white spaces. Okay, so this, for example, is one chunk, white space, another chunk, okay, white space, and so on. And that's how next is going to be able to navigate through. Hello, trailing empty, true, finish false, and the type is, it's put nothing because it's going to be lazy, so doing it in place. Okay, next word is some rejuvenate. So here we got rejuvenate first. So the first one that you have printed, we got rejuvenate. After that we have an empty space. After we have here the full sentence that you have printed. And the second one, we use the next on it. So after rejuvenate, we should have through. And that's what we got. Through here. Okay? We have the white space here. And here we got it at the end here. Cool. Let's have a break. Please like and subscribe. Let's go back in. Let's comment this out. I forgot to get rid of this. Yes, and now I can come back down. And let's do the most interesting example out of all of those. Last interesting example. Let's check that. Example 4, the last one. Let's free Mangakisa drinks equal, we just create a string here, and we're going to be just listing some drinks, different drinks available. We use this reference of a string, hot and cold coffee, strawberry milk. After we have cola, water, soup, and more. Okay, so those are free drinks available in Mangakisas in Japan. We are going to use format here. So here we're going to see the macro format and play with it to understand some nuances. So as we've seen in the explanation in the first part, we're using format also to concatenate strings together. Owned strings can be concatenated like that. Format can also be used to concatenate strings. Together. But here we won't do that. So that's not the purpose here. It's not just to do a concatenation. It's too easy, and there's no interest in that, because now you know that you can use plus with a reference of a string. You can also use format. You already know that. And now it's time to check out something a bit more deeper into those examples. Let some drinks in manga kisa. We're going to use format. And we're going to use the first variable that we used before. This is like making a copy of it, right? So we have formatted that, made a copy of it using format. Let's close those comments. So what are we going to do now? Now let's add some interesting extra checks on the memory location. So the question that you should have in your mind is, when I use format and I do the copy of the string, is it using the same reference string, or how does it work actually? Format is supposed to be a copy of string. We will check that by checking on the memory location. Cool. Let's check that memory location. So here we're using an assert equal, just like in Python when you're doing some test-driven coding. So you're going to do your test on different functions by doing some assertions. So here we will use it like in Python testing. Assertions. So here what we assert is that if we're making a copy of the other string, both should be the same, right? We assert, so we suppose that the two are the same, because they are copies. Should be the same, no? I mean, yeah, copy of the other one. One is copy of the other one. So we're going to use the first one, free manga kisa. We're just going to be comparing those two. And this assertion is going to be able to return to us if it is true or not. As const string, that's what we are converting it now. We use the reference of that, of free manga kisa drink. So reference, manga kisa drink. We do the same with the other one. Take the reference of it. Let's make this assertion. Some drinks in manga kisa has, we put the little start, const, string. I'm going to put some comments on that. Let's explain a little bit more lines of comments after we're done with the comments. Let's talk about first as. is to convert, to cast. Okay? So we're going to be converting the reference to the string, reference str, converting it to a string. That's what we're doing. We've seen that in the previous video when we have converted the usize to a u64. It was an index. We said index has u64. So as can be used to do some conversions. And the start const. Start, you would use it to get the ownership back. So is to get the value. I mean the ownership. The value of the memory location of that actual string. So here that's what a star const means. That's what we will be able to do, and to have it as a string. Let's close those comments. Are we ready? Not yet. We need to return something. So if the assertion is true, we're going to get the variables printed. If the assertion is not true, the assertion is going to be creating an error that is going to be stopping the app at its level, at its line. So the next line is not going to be printed. We got two strings. We still got two strings on the top. I believe so, because we haven't changed anything. We have our variable. We have our formatting, which is a copy of it. Okay, we treat that. We put it in here. Okay, we do the assertion on the reference of those variables. We get those variables and convert those to strings to be able to read the memory location address. And here we got string and string. We're fine. This we don't need to touch it. Cargo run. Okay, we got a warning because we didn't use allow dead code. You see I'm not printing the type here, but it's fine. So this is not something crazy. Let's see this in detail. Thread main panicked. So the panic means it stopped the application at this level. Assertion on the left side equal to the right side. That was our assertion. It has failed. It has panicked. So the left, this is the address of the one on the left. You see everything is the same until here. D8 F0. So we have different addresses. So format is making its own string. It's pointing to that string. Okay? I mean, it's making its own string, which is at another address location. So let's comment just next to it. Put the addresses, just keep those. And this is the right. Okay, so two different addresses, F0, D8. F0, D8, F0, D8. Close those comments. And our last comment. So here, it makes a copy. Now let's see here, format makes a copy and creates a new string. So that's more like in Python. When you use format, you can use it, it's okay. But it's going to be creating a new string. So like in Python, a new object is created. I found this very interesting. Let's close this comment. All right, we're done with that. We have seen methods to make some different operations on the REST string. We have at the same time seen more how an iterator works with a REST.next method returning an option. We have also used the REST format macro, which returns a string, as well as makes a copy of a string when interpolating a string variable by creating another one at a different location. That one was interesting as we could see those memory allocation addresses. I think that naturally we should probably focus on heap and stack for the next video. Tell me in the comment section. I believe that's what I'm gonna be creating. And use the REST book available online if you need to go more into the details of any topic, because that's what you want to be using REST for. Also, don't be mad and use ChatGPT, because you don't have any senior developer in front of you, because maybe there is human resources between you and that person, so you don't get hired, you don't get this access to those nice, amazing knowledge and experienced people. But ChatGPT can help for that, to explain the different concepts. Also, yeah, we are going to stop here. Hope that you liked this video. Thanks for the support again. Please like and subscribe, and see you next time for another Have a Break, Have a Rest session.